Okay, in this particular question, number 60 on page 42, it's kind of a cute problem because they've contextualized it into a James Bond thriller. Agent Bond is standing on a bridge 12 meters above the road. His pursuers are getting too close for comfort. He spots a flatbed truck approaching at 25 meters per second, which he measured by knowing that the telephone poles the truck are passing are 25 meters apart in this country. The bed of the truck is 1.5 meters above the road. Bond quickly calculates how many poles away that the truck should be when he jumps down from the bridge into the truck to make his getaway. How many poles is it? So in this particular problem, you should recognize that he's 12 meters above the road and he's trying to jump into the flatbed truck. So he's jumping from this point to this point here in the truck. We know that vertical displacement, and that's important in solving the problem. We're going to kind of invoke the first equation of kinematics, suggesting that delta y is equal to v naught t plus 1/2 at squared, recognizing that his initial velocity must be 0. He's just kind of jumping off the bridge. He's initially at rest. And that greatly simplifies this. It becomes delta y is equal to 1/2 at squared. Solving for the time of flight, we need to figure out how long it's going to take for him to jump from this point till he reaches kind of this threshold or the plane of the flatbed truck. So solving for t, we get 2 times delta y divided by a is equal to t squared. I'll then take the square root of both sides. I get an expression that looks like this. Plugging some numbers in, now I'm going to get 2 times my delta y, which is going to be the 12 meters above the road, minus my 1.5 meter height of the flatbed truck. Dividing that by my acceleration is going to be negative 9.8 meters per second per second. I've made a small mistake here, recognizing the way that I wrote delta y here. My delta y by definition is final minus initial position, and I wrote initial position minus final position. So I'm going to change that. You'll notice that that's going to help my sign. So I'm going to get 1.5 meters minus 12 meters. That creates a negative up here, so if I stick to the rules, I get a negative in the numerator and the denominator that cancel out. That allow me to basically get a positive number under the square root sign and avoid irrational numbers or imaginary numbers. Let's take a look at the solution here. Once you run that through your calculator, you should get about 1.464 seconds. Now we know how long he's in the air for, and the second part of this problem is just figuring out, all right, well, how far away should he then jump to time this so that he is at 1.5 meters above the ground after 1.464 seconds. Let's take a look at the truck. I'm going to use velocity is equal to distance over time. Rearranging this equation for distance, I get d is equal to vt. And then I can say that the distance, or how far in front of the truck he should jump, is equal to the velocity of the truck, 25 meters per second, times the time that he's in the air for, 1.464 seconds. This is what we've solved for in the previous part of the problem. You now get something on the order of 36.6 meters. But that doesn't answer the question, how many poles is that? So really the last step of the problem is simply to say, all right, well, we know it's 36.6 meters. We now want to convert meters to the number of telephone poles. So I'll say I'm going to multiply that by 1 pole every 25 meters, and I get 1.46 telephone poles, or dealing with significance, let's go ahead and call that 1.5 telephone poles.